All right, guys, Stat 1150. Our focus this week changes from hypothesis testing for means into hypothesis testing for proportions, and you'll see a lot of similarities in terms of the structure and the methods that we use. Just some minor things different. So should be a pretty quick video. I'm going to run through a couple of examples and talk about some things that'll help you on your homework assignment and help you get ready for this final exam that's coming up. So, guys, typically in hypothesis testing, it instead of seeing it as like one gigantic problem, it sometimes helps students to break it down into smaller problems. And your textbook does this in terms of 4 steps. First thing is state the null and alternative hypotheses. Second, state your level of significance and check your conditions. I'll run through examples of that. These things vary. These things are different than for the hypothesis testing for mean problems. We'll compute the test statistic and the p-value. And we'll use the calculator, but I'll also show you what's called the critical value approach. And then ultimately you just make your decisions. So we're going to use these 4 steps in working problems. And guys, I don't know what this is down here, but that's going to drive me insane. I can't get rid of it. It's something on the screen, but it probably won't bother you at all, but it's going to drive me crazy. So anyway, let's read the problem and see if we can figure out what's going on here. So it says, historically, the percentage of U.S. residents who support stricter gun control laws has been shown to be 52%. So apparently someone wants to test this with a newer sample. So this particular polling agency, Gallup Poll, randomly selected 1,011 people. I know it's random because I wrote the problem. So it's 1,011 randomly selected people, and of the 1,011, 495 said they were in favor of stricter gun controls. So we're going to assume the poll was given to a random sample of U.S. residents. Test the claim that the proportion or percentage, now guys, these are the same thing. The percentage here is 52%, and then the proportion is just 0.52. We typically look at the proportion because that's the way the technology addresses the problem. So anyway, we're going to test the claim that the proportion of those favoring stricter gun controls has changed. Now, in reading the problem, this is the kind of thing that you look for, right? Kind of initially is, has it changed? And notice that this could have been phrased 3 different ways. Has it just generically changed? So in that situation, we know that we're going to have a not equal to in the alternative hypothesis. Are we wanting to test that is increased? If that's the case, we'll use greater than in the alternative hypothesis. And of course, it follows naturally that if we wanted to test it as decreased, then we would use less than. So we have to look at the wording in the problem to indicate what sign we use in our alternative hypothesis. So for this problem, it's just has changed, so it's not equal to. So guys, let's go up here to the first thing. State your null and alternative hypothesis. So H sub O here is going to be about the claim, what's currently on record, what the current status quo is. And guys, here we're going to use a P instead of mu like we did in previous problems. The reason we don't have hypothesis testing for a mean, we have a hypothesis testing for a claim about a percentage. So we have to use the appropriate letter. So we're going to put that the claim is 0.52, and then the alternative hypothesis will always be the same letter. It'll always be the same number, and then we'll insert one of these inequalities according to the way that the information is provided in the problem. So this is just a generic has changed. So we're going to do what's called a two-tailed test, a not equal to. Okay? So this, and I've covered this before, and I'll give you an illustration here in a few minutes why we call it a two-tailed test. But the reason is we have two tails of rejection, but I'll give you an illustration on that. So these are called one-tail test because the tail of rejection corresponds to either greater than or less than. Up here, we're not giving a direction. It can be either higher or lower, it doesn't matter, so we put two tails of rejection. Here, we're specifying that it is increased, so the only way we could reject is if our rejection region was higher. So if our test statistic fell in that particular region. So again, I think that's going to be a lot clearer when you get an illustration from the calculator. All right, next thing we're going to do is state the level of significance. And right now, so this is part one. In part two, I'm going to set my level of significance of 0.05, which is the industry standard. That's typically where alpha is set. Now you're going to get a video after this one that's going to talk about alpha and beta and power and effect. No, we don't do effect size. Power and type 1 and type 2 errors. But we'll get to that soon enough. All right, the next thing in number 2 is make sure that we have a random sample, which we do. Do we have a large sample? All I mean by this is n times p and n times 1 minus p greater than or equal to 10. Well, our n in this case is 1,011. Our p is what we're hypothesized value. So guys, you can see that this is clearly up around, 500 or so. So it's clearly bigger than 10. And you can see that 1,011 times 1 minus 0.52, which, you probably could do that in your head like me, 0.48. So this is going to be up around 480 or 490, which again is bigger than 10. So yes, our large sample assumption condition is satisfied. Now the large population just says that the population from which we draw is at least 10 times as large as our sample. So what we do here is we take our sample of 1,011, multiply by 10, not to be confused with this 10, multiply by 10, and you can see in this case we get 10,110. Well, clearly there are more than 10,110 U.S. residents. I think in terms of U.S. residents, we're up around, around 300 million. So the large population condition is satisfied. Independence is something we'll assume. That just says that none of these measurements are related in any particular way. That's probably a little kind of a sophisticated concept for stat 1150. But so we'll just assume we have independence unless something just jumps off the table. And I will tell you, on your assignments and on your final exam, I won't have any of these violated. I'm not going to throw anything tricky at you. I just want you to have on your radar that there are certain underlying conditions and assumptions by which we can conduct these tests in statistics. All right, the next thing we're going to do is number 3, is we're going to compute the test statistic and the p-value. Well, guys, what I would do there is I would use the calculator. So I've got it right over here. So guys, I would go to stat, and I would go over to test, and I would come down to number 5, which is a 1-prop z-test. Now, the p sub 0, what they're trying to do there is they're trying to get you to put in the value for p that is in the sub-zero statement, which is your null hypothesis. So, guys, we're going to have a 0.52 there. Hit enter. X is the count out of the hole that has the condition that we're measuring. In this case, prefers stricter gun control. So we have 495 out of the total, which is 1,011. And the next thing is we choose one of the 3 inequalities that I talked about back over here. And since we have just a generic test has changed, we're going to use not equal to. So guys, go over and select it. No, I'm sorry, where am I going? Select it and then hit enter. So you truly have selected it. Now, I'm going to show you something later, but I just want to go ahead and work the problem so there's no confusion. And I'm going to come back to this and show you a picture of the calculation of the p-value. So all I want to do here now is go calculate. And I'll go to draw a little later on. I'll show you what's up with that. But right now, let's just hit calculate because we just want to work the problem. Now, the test statistic for these types of problems is Z. Now, remember when we did a hypothesis testing for mean, our test statistic was a T. It's a different distribution. It's a different type of tool. It's a different type of problem. So, we just have to put that on our radar. So our Z is negative 1.93. Now you're going to be asked to do some of these on my math lab. It may ask you to round to 3 or 4 places. So just round accordingly. And then the p-value. Now I'm going to write this out because there's some confusion sometimes when it just says p versus p. And then not only that, you've got your p hat, which is your count, which is 495 out of 1,011. This is your sample proportion. Sometimes there's a whole lot of p's going on in this this problem. So to specify that I want the p-value and not the population proportion, I'll write that out. Well, guys, regardless what you have, and you can see my mouse here circling, this underneath the z, you'll see the p. This stands for the p-value, not the p that we're actually hypothesizing about the population, the statement about the population. So the p-value here is 0.053. And again, that's easy to get using your calculator. All right, now let's go ahead and work number 4, and then we'll go back and show you the draw option. So the next thing is make your decision, and this is really pretty easy. What we do is we compare our p-value to our alpha. And if our p-value is less than alpha, we reject. If our p-value is greater than or equal to alpha, we fail to reject. Well, guys, our p-value here is 0.053. That's bigger than our alpha, 0.05. So we're going to fail to reject. And our statement is about H sub O, so we're going to fail to reject H sub O. So we're not necessarily saying this is a true statement, that it is 52% of the U.S. residents who support stricter gun control. All we're saying is the results from this test didn't result in rejecting that statement. Doesn't mean this is true. It just means there's not enough evidence to reject this statement. And that's the kind of the nuts and bolts of a test of hypothesis. Now, a while ago I said that if you are looking just at a generic not equal to, that we run a two-tailed test. So let me give you an illustration on why that is. When you run this on your calculator, this test, and go to number 5 like we did, but if you come down at the very bottom and go draw instead of calculate, what it'll do, it'll show you the calculation of the p-value. So if I hit enter, okay, what's going on here? All right, probably what happened here is I need to go up to stat plot. Let me hit enter here. I need to go up to stat plot. Probably I've got some plot turned on. So let's just go to number 4 and turn all the plots off. And let's go into y equal and make sure I don't have anything in there that could give me problems. All right, so that should take care of my problem. Let's go to test. And come down and go to draw instead. And it's going to work this time. So you can see that the calculation of the test statistic of negative 1.93 that we got earlier, you can see that the probability of getting a sample that large or larger, or that extreme or more extreme, is 0.0531. So this is our p-value. Notice that it takes the area in the curve, area under the curve, it looks at this negative 1.9 and finds the probability of that value or more extreme But it has to look on the other side as well, because we weren't doing a directional test. We didn't make a statement of greater than or less than. We just made a statement of, well, it's different. Could be lower, could be higher. We don't specify a direction. So we have to account for the area in both tails in the calculation of the p-value. Easiest way, if that's confusing to you, just remember these are two-tailed tests, so you're going to have two tails of rejection. These are one-tailed tests, as I'll demonstrate here in just a second. You'll have one tail of rejection. If all that's just way too much for you, just use your calculator and get your test statistic and your p-value like we did earlier, and you work your problem. Okay? All right, more politically charged items. The first one was on gun control. So let's just get a little crazier here and do some global warming. All right. So historically, about 58% of adult Americans believe that the Earth's temperature was rising. In other words, there's evidence of global warming. A March 2016 Gallup poll sought to determine whether this proportion had decreased. So guys, when I'm very carefully reading my problem, I look for those buzzwords on what I'm actually wanting to test. And those are the buzzwords right there, that it's decreased. So the poll interviewed 1,014 adult Americans. Looked like 527 of them believe that global warming is real. So we'll assume that the sample was a random sample. Okay, so what percentage in the sample believe global warming was real? Well, guys, our sample notation is given by p hat, and this is x over n. So x is the count out of the whole, which is 527. And of course, the whole is 1,014. So I'm going to go over here to the calculator and put 527 divided by 1,014. So we have 0.5197, which is about 51.97%. Okay? Now, test the hypothesis that the proportion or percentage of adults who believe global warming is less than 58%. Well, guys, the first thing I'm going to want to do here is state the null and alternative hypothesis. So H sub O is going to be P, because I'm testing a percentage. And and the reason I did this is the following. Do I put 58% there, or do I put 51.97% there? Guys, if you think this is what I put there, we are not connecting. We are making a statement about the population parameter in our null and alternative hypotheses. I don't need to test that my sample is 51.97. I know it is. I wouldn't even need to test this if I could go out and question all 200 million Americans, adult Americans, or however many adult Americans there are. I wouldn't even need to do a test of hypothesis for that. But I can. I'm using a sample, 1,014, to test a statement about hundreds of millions. So guys, the value that goes there is the value that describes the population, not describes the sample. I don't need a test of hypothesis to test that my sample is 51.97%. I know it is. I just collected it. It's right in front of me. So H sub A, same letter, same number. Go back to your problem and find the direction. Decreased means I'm going to test less than. So guys, I've got a one-tail test. And my rejection region is going to be less than to the left. So my p-value calculation is going to be calculated in the left-hand tail. All right, number 2, I'm going to set alpha 0.05 again. I'll just go ahead and tell you that all of the assumptions are met. We have a random sample, we have independence. For the same arguments before, n times p and n times 1 minus p are both bigger than 10, and we have more than 10,140 adult Americans. So the third thing I'm going to do is I'm going to use my calculator to create the test statistic, which is Z, and the p-value. So I'm going to go stat, go to test, go down to number 5. So I'm claiming 0.58 in the population. So again, that's my population parameter. I have 527 out of my sample that believe in global warming, and my sample is 1,014. But now I have to change to less than. Guys, choose the inequality that matches exactly the one that you have in your alternative hypothesis. So let's just do calculate first, and let's just work the problem and get it behind us. Now, so Z is negative 3.89. And the p-value, guys, if you get sloppy here, you'll get it wrong. If you get sloppy here and write down 5.037, you'll get it wrong because you're not coming all the way out to the right and realizing that, appreciating that this is presented in scientific notation. Remember, a p-value is a probability, and a probability has to be between 0 and 1. So the red flag, or Darbro screaming at the top of my lungs at you, telling you that 5.04 can't be the answer because p is a probability, p-value is a probability, it has to be between 0 and 1. So guys, pay attention here. The negative 5 says I need to move this decimal place 5 places to the left or insert 4 zeros. In front of the non-zero number. All right. Now this p-hat 0.5197. Well, we knew that before, didn't we? That's just the calculator giving you what we calculated up here. Of course, my sample size, well, our sample size, not my problem, is 1,014. So, guys, what's our decision? Well, our p-value is definitely less than our alpha. So we're going to reject the null hypothesis. So we're going to draw a line here. So the results from our test indicate that the percentage of people who believe in global warming is actually decreased from the historically believed value of 58%. So that's interesting. I don't know how valid these numbers are. I got this problem out of a textbook. So maybe Trump had a lot of. When was this taken? March 2016. So yeah, I don't know. Who knows? So let me illustrate the calculation of the p-value. So if I go over to test and go to number 5, instead of calculate at the bottom, I want to do draw to show you how the p-value will be calculated. Now this is a horrible problem because the p-value is actually calculated down here, but this is one standard deviation below the mean where I'm pointing right here, so that would be a z of -1, -2, -3, -3.89 is way over here. So let me adjust the window a little bit to give you a better, let's go to maybe -6 to +6 and graph it. I still don't think it's going to show up because, yeah, it's not going to do it. All right, well anyway, you couldn't see the calculation because this shaded value was so far down to the left, okay? All right, gang, part C, this is the last thing that we're going to work on here. Test the hypothesis that the percentage of adult Americans who believe global warming is real is different than 58%. Well, guys, what changes here, as you should know, is the sign in the alternative hypothesis. So that's all that changes. So we're going to be doing a two-tail test instead of a one-tail test. Alpha is still set at 0.05 or whatever the problem gives you. and then we'll use our calculator to make our calculations. Now you're going to see that the test statistic is going to remain the same, but you're going to see that our p-value is going to be different. So 0.58, same x, same n, but in this case we're going to do not equal to instead of less than, and calculate. Now guys, remember our old test statistic was negative 3.89, but our p-value was 0.00050. Well, that's going to change. Our test statistic won't, but our p-value will. So notice our test statistic is still, as I told you, would be 3.89, but our test statistic, our p-value, we have to go negative 4. So 1, 2, 3, 4, put in 3 zeros. 1, 0. So our p-value got larger, didn't it? And I still don't think we're going to be able to see the calculations. Let's see if we can. I think it's still too small. Yeah, still too small to see the shaded areas. Now, what I want to do, just to show you that the p-value calculation, I want to go back to when the p was less than 0.58 in the alternative hypothesis. I want to go back to that and play around with the data a little bit to show you that calculation. So if I make my p-value a little larger, and let's go up to about let's try 560. I think that'll probably do it. And I want to do less than. So my calculation of my p-value will be in the left tail. I want to show you that that's actually the case. So see, when I've got a test statistic that isn't as extreme as negative 3.89 was, I can actually see on my screen the calculation of the p-value. Notice there's no shading up here because we're doing a less than. Now, it probably goes without saying, but I want to demonstrate it anyway. What would it look like if we were going to test greater than? So let's let me make sure I choose something. 0.58. Let's choose 620 and see how that works, and then test greater than. Okay. And because we tested greater than, the calculation of our p-value is going to be up in the right-hand tail. See, like that. So, just want to show you that the shadings and the calculation of the p-values is just area under the curve, and it all corresponds to the decision we make early on, the sign that will be in the alternative hypothesis. All right, gang, that's it. I think that's all we need to do. There's going to be only a couple more videos, and there'll be one other R assignment that'll be due before the end of the semester, but it'll be due after the final exam. So I guess that's it. Take care.